First of all, we will write down the definition of the normal distribution. X is a normal distribution. There are two parameters of the normal distribution. One is mu, other one is variance, sigma square. X is a normal distribution with 61.4, 12.3 square. This one is the standard deviation. In the definition, at this place, we will write down the variance. Part number 1. Find the probability that a randomly chosen boy aged 16 years in Jimpuri weighs more than 65 kilograms. Now, in normal distribution, there are two types of distributions. Number 1, standard normal distribution. And this one is denoted by Z. Standard normal distribution. There is a distribution, and this distribution has mean 0 and variance 1. A distribution with mean 0 and variance 1 is considered to be a standard. Now, other normal distribution. If the mean is not 0 and the standard deviation mean and standard deviation are not 0 and 1, then the distribution is denoted by X. Now all the probabilities related with the standard normal distribution have already been calculated and written in a table. This one is the table. This distribution table gives us all the probabilities related to the associated to the standard normal distribution Z. If we will have any other distribution, other than 0, 1, other than 0, 1, then we will convert that normal distribution X into Z with the help of formula this one is the formula connecting the standard normal distribution and any ordinary distribution. Now we can see that in this distribution the mean is not 0 and mean and variance are not 0 and 1. So this one is X, this one is not Z. Part number 1, that the weight is more than 65 kg. So this one is the value of X, probability of X greater than 65. We want to find out the probability when X is greater than 65. First of all, we will convert this one into Z. The formula of conversion is Z is equal to X minus mu over standard deviation. Z is equal to 65 minus 61.4 divided by standard deviation, which is 12.3. And what is the final answer, please?
Zero 0.293.
0.293. This one is the final answer. Now we will use the table to find out the area under the curve. First of all, we will draw the diagram for the standard normal variable. In the standard normal variable, mean is 0. Now the value of z is positive 0.293 on the right hand side. Probability of z is greater than 0.293. So we will move towards the right side of 0.293 because z is greater than. This one is the required area we want to find. This one is the required probability. Now table always gives us the area less than any positive value. Table table always gives us the area less than a positive value of c and is denoted by phi of c, yeah, phi of a. Now if we will locate this value 0.293 in the table, then we will get the area on the left hand side. The total area under the curve is always 1. The total is always 1. So when we will have area less than 0.293, we will subtract that area from 1 and we will get the area on the left hand side of 0.293. Now we will divide this figure 0.293 into three portions. First portion is 0.2, second portion is 9, and the third portion is 3. Now we will use the table to find out the area less than this value. 0.293. 0.29, the first portion, we will locate this 0.2 in the first column. This one is 0.2. And next is 9. We will locate 9 in the first row. This one is 9. The value at the intersection of these two is this 0.6141. Now we will locate 3 in the next columns, in the next row, in which there is written add. Here we have 3 and at the intersection there is written 12. We will add this 12 in the last two digits. So this will be 0.6141 plus 0.0012. Probability of z greater than 0.293. First of all, we will write this one in terms of phi. 1 minus phi of 0.293. The value of 0.293 is 1 minus 0.6153. And what is the final answer?
0.3847.
This one is the probability that a person's height is greater than 0.293. Now, part number 2. For boys aged 16 years in Jimpuri, 25% have a weight between 65 kg and k kg, where k is greater than 65. Find the value of k. Now, part number 2. Probability that x is in between 65 and k is equal to 0.25. Is there any problem? Is there any confusion? First of all, we will convert all the data into mathematical equations. Any question about this?
No, sir.
Now, in this part, we have the probability 0.25 and we want to find the value of z. Now we will use the table in reverse order. If we want to use the table in reverse order, there should be a single inequality. If we want to use the table in reverse order, if we want to use the table in reverse order, there should be a single inequality. Now you can see that this one is a double inequality. There is 65 and k are on both sides of the inequalities. Now, can you find what is the area less than 65? Now, if we will draw the diagram of this, the diagram is this. We will draw this diagram for x. The mean is 61.4. 65 is on the right hand side, 65, and k is greater than 65, it is mentioned. This area is 0.25. Skandar, can you tell me what's the area less than 65?
1 minus 0.25.
So it's the same.
Mila, can you help me in finding area less than 65?
Sorry, what?
Can you help me in finding area less than 65, that is this area? This area, we want to find out this area. Can you tell me what is this area?
The one with k minus 65.
1 minus 65.
Huh?
Sorry, please repeat.
Shouldn't it be like the area till k minus the area till 65?
No. whenever we will convert, now listen to me carefully, whenever we will convert the, the double inequality into single inequality, we will have to use the previous part. In the previous part, we can see that we have area greater than 65, which is equal to 0.3847. Area greater than 65 is 0.3847. Then the area less than 65 is 6153.6153. Whenever we want to convert the question into single inequality, we will have to use the previous part. We will have to collect the information from the previous part. From the previous part, we can see that the area less than 0.615, area less than 65 is 0.6153. So this area is 0.6153. Now probability of x less than k is equal to. Now Mila, can you please help me? What is the area less than k?
K minus the mean over standard deviation.
The area between 65 and k is 0.25. The probability between 65 and k is 0.25. The probability less than 65 is 0.6153. What is the probability when x is less than k, Mila? Please rethink and tell me the answer. The area between 65 and k, look at this figure. The area between 65 and k is 0.25. The area less than 65 is this green one, this one, 0.6153. What's the area when x is less than k?
0.8653.
Yes, Mila, please respond.
Oh, okay. Yeah. So like 0.6153 plus
0.2.
0.25.
And what's the final answer, Mila?
0.8653. 8653.
0.8653. Now we have converted the double inequality into single inequality. Okay, whenever we are using the table in the reverse order, there should be a single inequality, and if there is a double inequality, then we will try to convert that one into a single inequality. And for this purpose, we will have to use the information in the previous part. And from the previous part, we came to know that the area less than 65 is 0.6153. So we will draw the diagram. The diagram will help you, and you will have a clear idea about the area. From the diagram, we came to know that the area less than k is 0.8653. Now, we want to find the value of k. We have the probability 8653. We will use the table in reverse order to find the value of z. First of all, we will convert this one into z. Probability of z less than k minus 61.4 divided by 12.3 is equal to 0.8653. Now we will let the value of z as a. This one is the value of a. Now we will decide that whether a is positive or negative. This one is the very important concept. This one is the very important step, in key step. Now, how to determine a is positive or negative? Mila, probability z less than a is equal to 0.8653. Draw a diagram for z. This one is the mean 0. The when z is less than a, the area is 0.8653. Area to the left of z is 0.8653. Total area under the curve is 1. A is positive or negative? Mila, please respond.
The the left side.
Sorry.
Wait, can you repeat your question?
Yes. Z is less than A. We will move to the left of Z because Z is less than A. The area less than A on the left hand side of A is 0.8653. This one is the diagram on the left hand side. A is positive or negative?
Positive.
Positive. Okay, let's say positive. Now this one is A. A is positive. Area on the right hand side of 0 is 0.5, on the left hand side of 0 is 0.5 because the total area under the curve is 1. Now area to the left of A is 0.8653. Yes. Suppose that if your assumption is A is negative, then this one is 0. On the left hand side of 0, the area is 0.5. On the right hand side of 0, the area is 0.5. So if A is negative, can the area on the left hand side of A be 0.8653, Mila? Mila, can the area on the left hand side of A be 0.8653?
Uh, yes.
Because the area to the left of 0 is 0.5. Can the area on the left hand side of A be 0.8653? Mila, this whole area is 50%. Can the red area be 86%?
Yes.
Area to the left of 0 is 50%. Can the area on the left of A be 86%? This green area is 50%. Can the red
Uh-huh.
area be 86%? It
86. No.
it should be smaller. It should be smaller. It cannot be. It should be less than 50%. It cannot be 86%. Now we came to know that A is positive. Should I repeat, Mila?
Uh-huh.
Sorry. Should I repeat?
Yes, sorry.
Okay. Now there is a shortcut to avoid this diagram because sometimes it is confusing to use the diagram. Now, if z is less than a and area is less than 0.5, if z is greater than a and area is greater than 0.5, then a is negative, otherwise positive. This one is the shortcut, otherwise positive. Now you can see that here we have less than a and the area is greater than 0.5. So a is positive. Use these two rules to determine whether a is positive or negative. Mila, should I explain this shortcut?
No.
Okay, please note down this. This one is a very important point. No. A is from here in this question. A is positive. Now we will use the table in the reverse order. The value of the probability area is 0.8653. This one is the table. We will look at the value 0.8653, 85, 86, 86, 8643, 8665. We do not have 0.8653. We will look at a value which is just less than 0.8653. Now 0.8665 is more than 0.8653. We will look a value which is just below. The value just below is 0.8643. We will add 10 into this one to make this one 0.8653. You can see that here we have this one is 10 and this one is under 5. So 1.105 is the value of C. Should I repeat this? Riba, Skandar,
No, sir.
No, sir.
Mila, should I repeat?
No.
Please,
No.
Mila, feel free to ask questions. If you,
No, it's fine.
okay,
You don't have to
okay.
repeat. Thank you.
Now 1.105 is the value of C. So A is 1.105 and K minus 61.4 over 12.3 is equal to 1.105. K is equal to 61.4 plus 12 into 1.105. What is the final answer?
$74.99.
74.9.
74.9 is the final answer. Is there any question do you want to ask about these two parts?
No, sir.
Important point.
The last part of question number 1. In another village, the boys weights of boys is also a normal distribution, with 99% of the boys weighs less than 97.2. Now, first of all, we will convert the equations into mathematical form. Probability that x is less than 97.2 is equal to 0.99, and 33% of the boys weighs less than 55.2. Probability of x less than 55.2 is equal to 0.33. Now we have these two equations. We want to find out the values of mean and the standard deviation. Part number 3. X is a normal distribution, mean is not given, and variance is also not given. Mu and variance are the parameters of the normal distribution. Now, consider the first equation. First of all, we will convert the first equation into z. Probability of z less than 97.2 minus mu over standard deviation is equal to 0.99. We will let this value of z as a. Let a is equal to 97.2 minus mu over standard deviation. Probability of z less than a is equal to 0.99. Mila, now z is less than a and the area is greater than 0.99. A is positive or negative? A is positive, and we have the probability. We will use the table in reverse order. The table is, we want to find out the value of z when the area is 0.99. Now, at the bottom of the table, you can see that the values of z in the second row and the area in the first row are written, which are more commonly used. Now you can p is the area and z is the value of z. Now here we have 0.99, and opposite to 0.99 the value of z is 2.326. So it is easy to use the more commonly used values from the bottom, 0.99. What was the value? 0.2, 0.326, 0.326, 0.326. Just a minute. Skandar, please repeat the value.
2.326.
0.326?
2.326.
Okay, 2.326. So the value of A is 2.326. 97.2 minus mu over standard deviation is equal to 2.326. 97.2 minus mu is equal to 2.326 standard deviation. This one is the first equation we have. Now we will use the second condition to form another equation. The second condition is probability of z x is less than 55.2 is 0.99. 3 3. This one is the second equation. Now we will use this one. First of all, we will convert this one into z. Probability of z less than 55.2 minus mu over standard deviation is equal to 0.33. We will let the value of z at b 55.2 minus mu over standard deviation is equal to b. Now we will decide that whether b is positive or negative. Now we have probability of z less than b is equal to 0.33. Mila, b is positive or negative?
Um, Positive.
Here we have
Negative.
less sign and the area is less than 0.5. So b is negative.
Negative.
B is negative. Now we have the area 0.33 and we want to find the value of c. We will use the table in reverse order. You can see that in the table there is no value less than 0.5. All the values are greater than 0.5. So we will subtract 0.33 from 1. We will subtract 0.33 from 1. So we have 1 minus 0.33 is equal to 0.67. Now we will locate 0.67 in the table. We will locate 0.67 in the table. In the commonly used values, we do not have area 0.67. So we will have to look into the table 0.67. This one is 0.6664. This one is 0. We have completely 0.67. This one is 0.44. Is there any confusion, Mila? Should I repeat?
No.
Okay. Zero 0.44. So B is equal to 0.44. Mila, is there any mistake in writing B is equal to 0.44?
Mm, should it be minus?
Yes, it should be negative. It should be negative. Negative. This one is the mistake. Most of the students do in the paper that they forgot to use the sign of A or B. Now B is 55.2 minus mu over standard deviation is equal to minus 0.44. Now 55.2 minus mu is equal to minus 0.44 into standard deviation. This one is the second equation we have. Now when we will solve these two equations with the help of substitution or elimination method, we can get the value of mu and standard deviation. Any problem regarding this question? Question number 4 is Josie aims to catch a bus which departs at a fixed time every day. Josie arrives the bus stop T minutes before the bus departs, where T is a normal distribution with mean 5.3 and variance 2.1 square. Find the probability that he has to wait longer than 6 minutes at the bus stop. Now this one is a question of normal distribution, and in part number 1 we want to find the probability that x is greater than 6. First of all, we will convert this one into z. Probability of z greater than z is equal to x minus mu over standard deviation. Z is equal to x is 6 minus 5.3 over 2.1. What's the final answer?
One over three.
0.333. Now we will draw the diagram. Diagram is very important. With 0 in the center, 0.33 is on the positive side, and we want to find out the area on the right of 0.33. With the help of table, we can only find the area on the left hand side of the positive value. This one is 1 minus 5 of 0.333. With the help of table, we will find the value of 0.333 and find the required probability. 3 0.33 0.6293 0.6293, and again under 3 we have 11, so this will be 0.6304. Mila, any confusion?
No.
Okay, 0.6304. So this one is 1 minus 0.6304. What's the final answer?
0.3696.
3696. Now part number 2. In part number 2, on 5% of the days, he has to wait longer than x minutes. Probability of x is greater than x is equal to 0.05. First of all, we have the probability. We will use the table in the reverse order. First of all, we will convert this one into z. Probability of z greater than x minus 5.3 over 2.1 is equal to 0.05. Let x minus 5.3 over 2.1 is equal to a. Probability of z greater than a is equal to 0.05. Mila, a is positive or negative?
Mm, negative.
Positive.
Here, Mila, we have z greater than a and the probability is less than 0.5. Z is greater than a and the probability is less than 0.5. So a is
Sorry, can you repeat that?
yes. If z is greater than a and the area is greater than 0.5, if z is less than a and the area is less than 0.5, then a is negative. Here we have z greater than a and area is less than 0.5, not matching these two conditions, so a is positive. Should I repeat, Mila?
Nope.
Okay, now as you can see that the area is less than 0.5, we cannot locate the we do not have any area in the table which is less than 0.5. We will subtract this from 1, we will get 0.95. Now in the table we will look for a value which is 0.95. First of all, I will try to use the more commonly used values. 0.95, yes, we have 0.95 here, and the value of z for 0.95 is 1.645. So the value of z is 1.645. A is equal to 1.645. So x minus 5.3 over 2.1 is equal to 1.645. What is the final value, please, Skandar? 8.75. Thank you. Now, part number 3. Find the probability that he waits longer than x minutes on fewer than 3 days in 10. Now, this one is 10 out of 3. No, what about 10? 10 is the number of days. Number of days is a discrete variable or a continuous variable. We count days or we measure days. Please respond.
Measured?
No, we count days. 10,
Oh, never mind that.
10 days,
Okay.
11 days, 352 days. We count days. This one is a discrete variable. And out of 10, we want to find out the probability of 3 or less. So this one is a binomial distribution in which this one is a x is a binomial distribution in which the total number of experiments are 10 and the probability that it will take longer than x minutes is 0.05. The binomial distribution has two parameters, n and p. N is the total number of experiments and p is the probability of success. Here in this question, we have n is equal to 10 and p is equal to 0.05. Now, fewer than 10. Probability of x is, fewer than 3. Probability of x is less than 3. This one is probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. The formula for the binomial distribution is probability of x is equal to r is equal to NCR p raised to r q raised to n minus r. Now, when we have x is equal to 0, r is equal to 0, and in this question n is equal to 10, 10 c 0, 0.05 power 0 and 0.95 power 10 plus 10 c1, 0.05 power 1 and 0.95 power 9 plus 10c2, 0.05 power 2 and 0.95 power 8. And please, Kandar, tell me the final answer. G. Mila is. Now part number 4. Find the probability that he misses the bus. If he misses the bus, this one is the time that he reaches before the arrival of the bus. It means that we want to find out the probability when x is less than 0. He has no time to wait for the bus. Now, on average, he is waiting 5.3 minutes for the bus. And if x is negative, then he will reach the bus stop after after he has missed the bus. Should I repeat? Ariba?
No, sir, it's okay.
Okay. Now we want to find when x is less than 0 is equal to, first of all, we will convert this one into z. 0 minus 5.3 divided by 2.1. What's the final answer?
Minus 2.524.
Minus 2.524. On the left hand side, and we want to find out this area that is less than this value. Now you can see that in the table there are no negative values. We will flip this figure. Two, 5 to 4. We want to find out this area. This one is on the right hand side. So this one is 1 minus phi of 0.2524. Sorry, 2.524. This one is the answer. Now we will attempt a question in which we will convert the binomial distribution into normal distribution. In question number 16, when visiting the dentist, the probability of waiting less than 5 minutes is 0.16. Probability x is less than 5 is equal to 0.16, and the probability of waiting less than 10 minutes is equal to 0.88. There are two conditions given, and we will find out the we will use the table in the reverse order, and we will find out the values of mu and standard deviation. The time is short. Question number 17. A straw fits into the hole if the diameter of the straw is less than 3 meters. The diameters of straws have a normal distribution. X is has a normal distribution with 2.6 as the mean, and the standard deviation is 0.25. So the variance is 0.25 square. Now part B. 500 straws are chosen at random. Use a suitable approximation to find that at least 480 straw will fit into the holes in drinks cartons. Now we have 500 straws, and any straw fits into the hole has the probability. We will have to look at the answer of question number 17. That is, what is the answer of the answer to part 1, that a straw fits into the hole is 0.9. What was the 9452? I think this one is the answer. Now x is a bind. Now 500 straws. We will count the straws, or we will measure the straws, that how many of them fit into a particular hole.
Count.
Count. This one is a binomial distribution. X is a part number 2. X is a binomial distribution. 500. We have 500 straws, and the probability of success is 0.949452. This one is n, and this one is the probability of success that a straw will fit into the hole. Now we want to find the probability that x is greater than equal to 480, that x is greater than equal to 480. Now we will have to find probability of x is equal to 480 plus 481 plus 482 plus 483 plus 484 plus 485 up to 500. It's a very complicated calculation, and we cannot find out the probability for such a large number. So we will convert this question of binomial into normal distribution. Now, in a binomial distribution, it is n and p, while in a normal distribution, this one is mu and variance. Mu is np and variance is npq in a binomial distribution. So x is a binomial distribution with 500 comma 9452. What is np? 500 into 0.9452, please, quickly.
472.6.
And npq, q is 1 minus p.
25.9.
25.9. Now we have the mean and the variance of this distribution. Now we want to find that probability of x is greater than 480. Now the most important concept in this conversion is the continuity correction. You will miss this step. Now to apply the continuity correction, we will draw 3 rectangles. We will write down 480 in the middle and write down and draw the 2 neighborhood rectangles. Now this one is 480, x is greater than equal to 480, greater than equal to 480. So we will move towards the right side of 480. Should we include 480 or not?
Yes.
Yes, we will include. So we will write down 479.5 or 480.5.
480.5.
No, if we will write down x is greater than 480.5, then we will miss the rectangle of 480. We will have to write
Okay.
down
479.5.
479.5. Now we will convert this one into z. Z is equal to 479.5 minus 472.6 divided by under root 25.9. What's the final answer?
1.36.
1.36.
1.36. Okay. 0, 1.36. This one is the region, and this one is 1 minus 5 of 1.36. And you can locate the area less than 1.36 and find the answer. Now we should practice the continuity correction when probability of x is less than equal to 3. We will draw 3 rectangles, 3 2 and 4 less than equal to 3. 3 is included and on the left hand side. Skandar, we will write 2.5 or 3.5.
2.5.
No, if we will write down 2.5 and we will move
3.
to the left, we will miss the rectangle. If this one is x is greater than equal to 3, then we will draw three triangles. We will move towards right. We will include 3. Now we will practice some more questions uh, about the continuity correction. If we have x is less than 3, the method is we will draw three rectangles. 3, 2, 3 in the middle, 2 and 4 in the neighborhood. Now we need the we will move on towards the left of 3 or right of 3, Mila. Mila, x is less than 3. We will move towards left or right. Mila, can you hear me?
Uh-huh.
X is less than 3. We will move towards left of 3 or right of 3.
Left.
Okay. Should we include 3 or not?
No.
Okay. Now this one is the region. Now should we write 2.5 or 3.5?
2.5.
Yes. Is there any confusion, Mila?
No.
Probability x greater than 3. Now again we will draw three rectangles with 3 in the middle and 2 and 4 in the neighborhood. Skandar, should we move towards right or left of 3?
Right.
Should we include 3?
No.
This one is the region required. Now what should we write? 3.5 or 2.5?
3.5.
Is there any confusion, Ariba, Skandar and Mila?
No.
Okay.
No.
No.
Now question number 17, part 3. Justify your answer that why we will use normal distribution instead of binomial distribution. The justification is if NP is greater than 5 and NQ is greater than 5, then we will use normal distribution normal distribution approximation. Then we will use normal distribution approximation. Now you can see that n is 500 into 0.9452, which was
472.6.
and 0.1648, 0.0648.
32.4.
I think that calculation is some mistake in the calculation. But you can see that both are greater than 5. Both are greater than 5. So when both are greater than 5, then we will use we will leave the binomial distribution and use the normal distribution to find out the probability. This one is all about the normal distribution. If you have any question, you can ask.
Okay, sir.